We're going to look at the algebra of functions, and I'm going to try to break it up into 2 recordings. If I forget, well, I can always split it up when I edit it. We're looking at algebra of functions. So far with quadratics, we looked at ax squared plus bx plus c, and then see what that looks like. And just for a little review of that, if I go to my Geogebra, I can say I'm going to have a value for a, and I can have a value for b, and I can have a value for c. And let's just say, let's show the function ax squared plus bx plus c. Geogebra, wonderful place. There's ax squared plus bx plus c when a, b, and c are all 1. Well, let's first of all mess with a. How do we expect this to behave as I mess with a? Well, a is multiplying x squared. So as I multiply it by more, that parabola goes up higher, faster. As a gets smaller, that parabola doesn't quite go up as fast. And then if it becomes 0, well, there is no x squared in there, and I have a line. And then when a is negative, my parabola goes down. That's ax squared plus bx plus c. If I adjust b, well, that's what's multiplying x. That just kind of shifts my function around. If I zoom in, it shifts my function around where 0 is. And if I multiply this or modify the c, c just moves my function up and down. So that's ax squared plus bx plus c. But now we're going to look at something slightly different. We're going to look at, instead of ax squared plus bx plus c, we're going to replace a and b with multiplying by some other functions, like f of x and g of x. And let's say we give c some value of constant. Well, instead of ax squared plus bx plus c now, I'm multiplying by this function x and multiplying by a function g of x times x. And you think, wait a minute, that looks crazy. Well, let's go at it slow, and it maybe won't be so hard. So let's take a look at that with an example, and then maybe we'll come over to Geogebra and play with that as well. So, when we talk about algebra functions, and I'm going to get my little drawing tool on. When we talk about algebra functions, let's not panic and look at it all at once. Let's just look at the one thing at first, just this part here. Don't worry about all those others. Looking at all sorts of f and g's and x's, that's really scary looking. Just focus on that first part. Then we'll get to the next part, and you'll realize, wait a minute, it's not all that hard. Let's just look at this first one. I have a function f of x and a function g of x. And basically, they're defining a notation. When I say this, f of x plus g of x, and I'm going to hide the rest just to not be scary. When I have this function f of x plus g of x, what that means is take f of x, whatever it happens to be, and we're just adding g of x. So let's look at an example, a simple example. If I have f of x equals x plus 1, and I say g of x, let's say g of x is x squared plus 9. When I say f of x plus g of x, all I mean is take whatever f of x is, x plus 1, and sometimes it's very helpful to put parentheses around it, especially when you have signs to worry about. I'm adding that to g of x, which has been defined as x squared plus 9. So that's all that means. When I say f plus g of x, that's how I pronounce it, f plus g of x, what that means is take the function f of x, add it to the function g of x, whatever they are defined to be. And this becomes a quadratic, right? I simplify that. That becomes, well, let's go down a little bit here. That becomes, well, actually, I'll just draw it in the one below. That becomes, that becomes, what does it become? Let's put the x squared together. There's 1x squared. Whoops. There's x squared plus an x plus 10. 1 plus 9. So f plus g of x, we just mean subtract or add f and g of x. Now, the other one maybe isn't so scary. Think, okay, if I can add two functions together, well, I can subtract a function from another one. So when we see f minus g of x, let's say I'm going to use the same function. Let's do f minus g of x over here. F minus g of x, all I'm saying is take f, x plus 1. We'll put it in parentheses to just make it clear. That's f of x. Subtract g of x, which is x squared plus 9 in this little example. And then simplify that. Now this is where the parentheses are very important, right? Because I'm subtracting x squared, and I'm also subtracting a 9 when I do the subtraction. When I'm subtracting the quantity x plus 9, remember that becomes, I'm subtracting x squared, and I'm subtracting that 9. So taking the parentheses away makes that become that. And now I can combine these two because they're both constants. So I'm adding 1, subtracting 9. That becomes a negative 8. Adding 1x, there's no other x's around, so it is just 1x around. And there is a negative x squared left over. So f minus g of x is the same as, well, take whatever f of x is, as defined over here, subtract whatever g of x is defined as, and then it becomes just a quadratic. Sometimes it becomes, sometimes other things subtract out. There's usually an x around somewhere. Sometimes there's still an x squared hanging around, depending on what f and g of x are. So combining f of x and g of x, we call this algebra of functions. Now it's a little abstract, takes a little thinking, and we'll do some practice on it. Well, you can imagine now, because I can add them, I can subtract them, I can also multiply them and divide them. Now that's the part that often comes out a little scarier looking. And let's just do what the multiply would look like for f of x times g of x. Well, that would become x plus 1 times, times x squared plus 9. In this little example of those two functions. And all you do with that, well, you can multiply it out, or you feed it to Geogebra and see what the curve looks like. If we want to multiply it out, let's just go ahead, multiply it out. That becomes, let's see, x times x squared gives me x cubed. X times 9 gives me plus 9x. See how I did the x times both those things? And now I do a plus 1 times both those things. Plus x squared plus 9. See how this is f of x? And this is g of x. I'm multiplying together. That's where the parentheses are super important when you're doing the multiply. X times both those things, there, plus 1 times both those things in g of x gives me that. Is there anything to combine? Nope. But we do like to list them in descending order. So we like to list it as x cubed plus x squared plus 9x plus 9. But all I did was have the definition of f of x in parentheses, multiply by g of x in parentheses. And when I divide it, I just put one over the other. Let's do over here, x plus 1 divided by x squared plus 9. This is usually the hardest because you can't simplify that very well, so we just leave it that way and when we know what our x is, then we'll do the division. So you can leave it like this until someone says, okay, find when x is 0, what do I get? Or when x is 3, what do I get? But otherwise, we leave it in the form. There's no way to simplify that any further. And I can even leave it in this form and say, well, I'll find what f of x is. You give me an x of 3, I know what f of x is, and I would know what g of x is. I'll just multiply them. I don't even have to expand them out. Just tell me what f and g are, and I'll then multiply them together after I figure out what that comes out to be. And that's the tricks we learn as we do algebra of functions. We can say, I'm going to just figure this out, or I'm going to expand it, and maybe it'll be a simpler problem. Usually, it's simpler to just leave them in the original form. They're multiplied together. So let's do a little bit of practice with this now. In their example, they have a different f of x, x minus 3, and g of x is x squared plus 7x minus 5. Well, when we add them together, can you see that that would be x minus 3? I like to do the parentheses just for good practice, plus, in parentheses, x squared plus 7x minus 5. And all I need to do is, well, since I'm just adding them, let's see, I have a minus 3 and a minus 5, that becomes a negative 8. I have an x and a 7x, that becomes a 8x. And there's only still one x squared hanging around, so that becomes that. So, two functions together give me that. Let's see how they do it here in the explanation. Notice, I'm not going to worry about the subtraction yet. Let's just jump down to the addition, and then we'll come back to the subtraction. When we add them together, remember the notation f plus g means, well, take f of x and g of x, add them together. There they have the two combining. Oh yeah, they got the same answer. Now they didn't do the there's not a lot of work to do. You can just say, we'll combine. How many x's do we have? Well, we got one x here and a 7x there. That becomes our 8x. And notice how they like to put them in descending order of exponents. If you don't put it in exactly that order, you still have the right answer. But it's best, and it's just common practice to do descending exponents. So there's the f of x plus g of x. Now, before we look at their answer, let's think through ourselves g minus f of x and see what it gets, what it comes out to be, before we see their work. So let's do g minus f of x right here. And we'll, do we need to change? I'll change the color just for fun. All right, so g minus f of x is, well, x squared plus 7x minus 5. Now you don't have to put the parentheses there, but let's just do it for good practice. And then I'm subtracting f of x. Because remember, g minus f of x is the same as g of x minus f of x, which is x minus 3. Now see how that sign and the parentheses become very important. If I take away the parentheses, what does that become? Well, that becomes a minus an x, and that becomes a plus 3. Because I'm subtracting a negative 3. Now this can leave the same, so I've got x squared plus 7x minus 5. Now what do I get? Let's see, there's no other x squareds around, so I have still one x squared left around. There's a 7x minus an x, that gives me a 6x left over. And there's a minus 5 and a plus 3, that becomes a minus 2. Notice I cannot combine x squared plus 6x. That does not become like 7x plus 1. I leave that alone. That's the best I can simplify it. Any exponents, they can't be combined with different powers of x. Let's see if I got the right answer. Let's go down to their explanation of f or g of x minus f of x. G minus f of x. See how it's the same as g of x minus f of x. They do put the parentheses in there because that negative 3, when you're subtracting over 3, that becomes a plus 3. And let's see that they jump ahead and just do the solution. They get x squared plus 6x minus 2. Yep, same answer. So breaking it apart, be careful. This is the super important part. If you have parentheses around whatever you're subtracting, because those signs can really mess you up, especially when you're subtracting. Adding, you can just add them together. You don't have to worry about reversing signs. But put it in parentheses when you're subtracting the function, because that parentheses negative 3 becomes a plus 3 when I take out the parentheses. Now, this is the part where it gets a little scary, but don't panic, because we can always say, I'm going to work with it this way. Let's just practice multiplying out. I'm multiplying x minus 3 times x squared plus x minus 3 times 7x. See how they're taking the x minus 3 times each of the elements inside of there. X minus 3 times x squared, x minus 3 times 7x, and plus an x minus 3 times a negative 5. And that's where some signs will, you got to pay real close attention to that sign there. Putting them together now, that becomes x cubed minus 3x squared. This becomes x 7x squared minus 21x. This will become negative 5x plus 15. And so let's see how they do it. There's my x cubed minus 3x squared, 7x squared minus 21x minus 5x plus 15. Let's see, we combine. How many x cubed do we have around? Well, we still only have one x cubed hanging around. We have a minus 3x squared plus 7x squared. That becomes a plus 4x squared, right? Go down 3, go back up 7. You get positive 4. Minus 21 minus another 5 makes that become 26x. And there's only one constant hanging around. Now all this is to just show you that when I multiply f and g, I can come up with a whole other polynomial. It's usually much more complicated because I have one quadratic or linear equation multiplied by another. That usually becomes a more complex function. Dividing even becomes more complex. They like to just leave it. Don't worry about trying to simplify this unless some factoring comes out. I see that x squared plus 7x minus 5, well, is there two numbers that when added together be equal to 7 and when multiplied give me 5? Well, I don't think I can factor this. But if there happened to be an x minus 3 when I factored this, then that actually can simplify the division sometimes. But otherwise, we just leave it f on top, g on the bottom, and when we have an x, we just plug it in and figure out what the numbers come out to be. When I say, what's f over g of x when x is 3? And I just plug a 3 in. Oh, and I know I'm going to get a 0 on the top. I don't even have to worry about calculating that. I know it's going to be a 0. If this happens to be a 0, then I'm in trouble because it's illegal to divide by 0. So I'll have to say, oh, it's not defined whenever this happens to be 0. And that's where the quadratic part comes in that we've already learned, that when we have a function underneath, when that is equal to 0, some crazy things happen to my function. It goes like not defined. And so that's the parts that we say, what? Does our function blow up at particular places when this comes to be 0? And I can use my quadratic equation to find when this comes out to be 0, what values of x cause that to be 0. And I'll say, well, mathematically, I don't know what happens there. Everywhere else, here's what my curve looks like. Now, just for a little bit of brain relaxation now that we've looked at something kind of scary, let's just put these functions into our little friend, Mr. Geogebra. What functions do we have? We have x minus 3, x squared plus 7x minus 5. Let's show you how we can use GeoGebra to just understand how this might be working. So I come over here. I'm going to erase all that I have. Let's see. Is there a delete all? I thought there was a delete all somewhere. Tools. Well, I'll just delete them one at a time and start over. Here we go. That was my quadratic. Okay? So I can put in one function. What was it? X minus 3. So I come here and I just start typing in geogebra.com. I don't even have to log in. X minus 3. Minus 3. And it shows me, oh yeah, if you give me x minus 3, that's what the graph looks like for x minus 3. When x is 0, I'm at negative 3. And as x increases, it just increases linearly because I don't have any x squareds in there. And when x is 3, that's when I cross the x-axis. All right, now let's put g of x in there. X squared plus 7x minus 5. I just type in here. X caret 2, down arrow, plus 7x minus 5. And I'd see, wait a minute, is that a line? Well, let's zoom out a little bit. Oh, that's a parabola. Sure you got it right? X squared plus 7x minus 5. There's my parabola. There's my g of x. Now think to yourself, what would happen if I added these two together? Well, I could do it point by point. I could say, well, right here, I've got a negative 5 and a negative 3. When I add them together, it'll be down here at negative 8. Here, when I add them together, well, there's a 0, and it'll be that. So it'll be right on this line. Here, when I add them together, well, I got a 0 here and a big number here, so it's going to be way up there. Well, let's let GeoGebra do the adding together. I can just do this. I can do g parenthesis x plus f parenthesis x. It gives me, doesn't even combine terms. It just says, okay, that's what it'll come out to be. I hit enter, and that's my blue curve. The two functions added together, and let's see if this makes sense. When I add them together, as I get really big numbers, and I zoom out, look at that. It's almost the same as g of x. That x squared is like takes complete dominance over anything. And as I get really big numbers, it's almost f of x and g of x are almost, or sorry, g of x and the g of x plus f of x are about the same. Because the x squared takes over. But as I zoom in closer to where 0 is, and the x squareds don't take over so much, especially as I get close to 0, x squared becomes really small. The functions added together are just like adding two lines together. And as I get really close, where x is almost 0, well, it's like adding the negative 3 and a negative 5 gives me the negative 8. So there's my f of x plus g of x, graphed in blue. F of x plus g of x, graphed in blue. There's my g of x, there's my f of x. Now let's look at, what was the one they did next? They did g minus f of x. Well, I can do this. I can type this. I think GeoGebra lets me do this. I can type it in g minus f parenthesis x. It actually does the work for me and will calculate the g minus f of x function. And what do I get for a function? Something a little stranger looking. It's a parabola. What? Oh, that's for somehow an extra x got in there. That's messed me up. There we go. It's a parabola, and I'll turn off the g plus x. Now do you see when I add them together, well, when I have a negative x, it kind of pulls the parabola a little bit down here. Otherwise, with really big x's, again, it looks very much like just the x squared. The x squared takes over with really big x's. But as I get close to 0, the g minus f of x is like, okay, I subtract negative 3 from a negative 5, gives me a negative 2. So there's my g minus f of x. The line, think of it this way, the line has a mild influence on the parabola if I either subtract it or add. Now, this is where it gets a little bit weird. Let's do the multiplying f of x times g of x. Well, let's see. When f of x is 0 here, well, I'm going to be multiplying 0 times something, so it's going to cross at 0 here. Let's just do the, let Geogebra calculate for it, f of x times g of x. G of x. G of x. And there is, wow, what do I get there? I get a little squiggly going. When I'm multiplying, I get an x cubed in there, and when I have an x cubed, that usually means I have a little more squiggly looking function. F of x, g of x, there is my f of x times g of x. When you have a cubed in there, your function does a little more wiggling around. You think that looks kind of weird? Let's do, is it f over g? Let's do f of x divided by g of x. F of x divided by, gotta get my division symbol in here, divided by g of x. Now look what I get. Strange looking function. Stranger things here. I'll put f of x and g of x in there. Let's go look closer here. What's going on here? When I divide f of x over g of x, remember g of x is, or g of x is that parabola. When that parabola hits 0, I'm dividing by 0, and things go crazy, where g of x comes out to be 0. Here at about 3/4, and down here at around negative 7 3/4. Look at what happens when I'm dividing by that g of x. When g of x becomes 0, that red function, f of x over g of x, goes wacko, one direction or another, all the way up to infinity. Everywhere else, it's kind of boring, just pretty flat here. Here it's pretty flat, because I'm dividing x minus 3 divided by x squared and 7x. Well, unless I'm close to where this is turning out to be 0, I'm almost dividing by the same number, and I get a pretty flat, boring looking curve as I get big numbers. When the numbers are big, I have x divided by x squared, or 1 over x, and 1 over a really big number is a number really close to 0. So just a little bit of recreation graphically, letting GeoGebra do the work for us with two pretty boring looking functions, just a line and a parabola. When I start dividing, things can really go crazy, and that's why we pay attention to where that number on the bottom of the denominator, when that becomes 0, that's where crazy things happen in my curve, and that's where my model blows up, or my device blows up because everything gets really hot and interesting things happen. Or mathematically, we have to say, you know, our model may be wrong. We don't really know what happened there because the math goes really crazy. Okay, that was just a little relaxation for your brain. Just graphically think about that. Hopefully that helped you think, oh yeah, when I'm dividing by this g of x, when that becomes 0, yeah, that graph's going to really go crazy one direction or another. That's why it's undefined when it's 0, because I don't know, is it that infinity or that infinity? Well, it's not defined when you divide by 0. Okay, back to the text then. As we get the various combinations, we do algebra of our functions, we feed that in and we get the different numbers. If I get this and now I say, okay, give me an x, and let's just say, okay, I know what f plus g of x is. Well, Now tell me, what is f plus g of 2? What do? Well, just plug a 2 in there. 2 squared plus 8 times 2 minus 8 gives me 4 plus 16 minus 8 gives me 20 minus 8 gives me 12. Okay? F plus g of 2 is equal to 12. I just plug a 2 in where the x is. Well, I could say, you know what? I don't have to do it there. I could do it here. When x is 2 there, what do I get? I get a negative 1, right? 2 minus 3 gives me a negative 1. And when x is 2 here, well, I get a 2 squared. I get a 4 plus 7 times x minus 5. Or 2, when 7 is when x is a 2, I get 4 plus 14 minus 5. Or I get 13. F plus g, negative 1 plus 13, gives me a 12. I could have said, I'll calculate them separately and add them together. I will get the same answer. And that's what we do when we come down later. We plug in values of x, and we can say, well, I'll do one thing. I'll figure out what f plus g is of x, plug in x, or I'll keep them separate, find out what f of 4 is, and then find out what g of 4 is, add them together. So they show that as an example in the textbook. We're going to jump ahead, though. Well, actually, we'll go through a couple of these, and then we'll look at how this can be done using graphs and charts, and all you have to do is find f and g at a particular point. You don't have to do the combo. So they're showing you, if I want to find f plus g of x, given a particular value of x, well, they say, well, let's combine them first, figure out what f plus g of x is for these two functions. Is that the correct answer? Well, let's find out. Well, we figured it out from above. They're using the same f of x and g of x from up above. We know f plus g of x is this. Well, if I want to know what is f plus g of 4, well, I'll just plug 4 in there, and 16 plus 32 minus 8. 16 plus 32 gives me 48, minus 8 gives me 40. Yes, they got the right answer. Plug in the 4 where the x is when they want f plus g of 4. See how they say when x equals 4, that means put a 4 in where you see x's and then just multiply it out. Same for f minus, well, they say, okay, that's one way to get the answer. Well, what if we did it without combining them? Let's just figure out what f of 4 is, and then what g of 4 is. Well, how do we get f plus 4? Remember, f of x is x minus 3, and g of x is x squared plus 7x minus 5. Well, f of 4, they show you there it is, f of 4 is x minus 3, 4 minus 3, that gives me the 1. G of 4 is x squared plus 7x minus 5, that gives me 39. And add them together, 39 plus 1 gives me 40. One, I combined them first and then plugged in the x. The other, I plugged in the x, the 4 for the x, separately, and then combined them. Two ways to solve the problem, and this is the world of mathematics. Those genius mathematicians find all sorts of theories way beyond these quadratic and algebra stuff, and they say, there's one way to look at it this way, and that becomes a really hard calculation. Our computers blow up. But some genius figures out, that very complex equation can be simplified if we look at it this way, and I'm just adding these two simple functions together, and we can solve the problem and win the Nobel Prize. That's essentially what those mathematicians are doing out there for the really hard problems. They're thinking of, what if I solve the problem a slightly different way, like instead of combining them, keep them separate, and then, look at that, the answer comes out, and we have determined the Big Bang Theory. That's essentially what Stephen Hawking did with all the math and physics. That's where they come up with these super crazy theories. They're doing these things. And so in your future math, you can think to yourself, hey, there's more than one way to solve the problem. Let's find the one that takes the least amount of work and stays more accurate. The one that takes the least amount of work is most likely not to go wrong, and then you can find the answer. If you find looking at different ways gets you a different answer, you can say, wait a minute, something's wrong there. Either they have their math wrong, or they've defined the problem wrong. Now, when we have f of 0, f times g of 0, that's usually pretty easy because when you have a 0 for x, things get a little simpler. And we see when you have a 0 for x, we get minus 3 times a minus 5. So f times g of 0 gives us 15. And their last example, f divided by g. Now that becomes, that was a kind of a scary looking function. This over this. This is a time where it's probably easier to solve them separately and then divide. And let's see what they did down there. They said, okay, solve f of negative 1 on the top. I get a negative 4. Solve for g of negative 1, and I get a negative 11. And then the answer is negative 4 over negative 11. They had a little typo there. Gives me 4 over 11. Now you could have just said, well, let's take this. Where did it go? Let's take this and put a negative 1 in for x. I would have gotten the same answer because there's f of x, there's g of x. Would have become negative 4 over negative 11. Sometimes, though, this does simplify. Usually when this simplifies, it makes it an easier math when things factor out. And we'll look at that. Whenever things factor out, you still have to say, if there's an x minus 3 that factors out down here, you'd say, well, unless x is equal to 3, we can factor out x minus 3 and make a little note. When x is 3, it's undefined because 0 divided by 0 blows up mathematically. But for all other x's, I can divide out an x minus 3 and get maybe a very simple answer like 1 over x minus 2. So when you see this, it's a possibility it may simplify, but you have to be careful to worry about dividing by 0 here. That's where the division part can blow up. Okay, this was doing it all algebraically, but suppose I'm gathering data on my computer and I only have tables of my x value and what I get for f of x and g of x at specific points. How do I do the combo? Well, the only way to do it is I have to do f of negative 1 plus g of negative 1 because I don't have an f plus g of x in my table. Well, actually, I could make an f plus g of x, couldn't I? I could just say f plus g of negative 3 is 4 minus 1 is equal to 3. I could fill in my table. Or just say, wait a minute, I only care about f of negative 1 plus g of negative 1. I don't have to worry about filling my whole table up if I only care about this value of x. See where f of negative 1 means x is equal to negative 1. That's what I care about. Well, f plus g of negative 1 is f of negative 1 is 2 plus g of negative 1 is 3. So if I want to say, well, I care about particular value, I know f plus g of x, I can fill in that table. Or let my computer fill in that table when I have 1,000 x's and some 1,000 measurements of f and g from my data collector. And someone says, well, if I combine them, what was it when x was equal to 4? Oh, there you go. Add those two together. F plus g at 4, 0 plus 2. How about f divided by g at 3? What would I do? I have to find where is x equal to 3. So that is equal to f of 3 divided by g of 3. When you see that, automatically think to yourself, that's f of 3 divided by g of 3. Well, f of 3 is, here where we have x equals 3, f of 3 is 1. G of 3 is, we got a problem. F of 3 is 1, g of 3 is 0. What's that become? Not infinity. Does not exist. Anytime with a 0 at the bottom, we got a problem. And there it is. G, let's just verify, when x is 3, g is 0. Yeah, we got a real big problem there. Let's see how they explain it. F plus g of negative 1. We find f of negative 1 plus g of negative 1, and I get 2 plus 3, and I get 5. Let's see how they explain the next one. F of g of 3 is f of 3 over g of 3. We find them, and we get 1 and a 0, and yes, indeed, does not exist. We can't divide by 0. Key thing here is, remember, in my table, here's the numbers. I know, this is my domain in my table. I know the values of f of x and g of x only for these x from negative 3 to 5, and I don't know what's in between. I just know, for these particular numbers, I know what f and g are. If someone said, what is f of 6, or divided by g of 6, 6, or f over g of 6, what would I say? I don't know f of 6, and I don't know g of 6. I'd have to say, well, that's something divided by something. I don't know what it is. It's not in my table. I'd have to say, sorry, can't tell you. It's not in my data. When I say does not exist, I just say unknown, based on the data I have, I don't know what it is. Maybe someone has to go out and measure it, and then they'll tell me the answer. So you can't have any x's. If you have a table, you can't have any x's other than the x's that are in your table. Anywhere else? It's not told. I don't know for that table. So f of 3 over g of 3. I can do the same thing with graphs. And usually the graphs are nice. They usually, to be nice to us, they're asking us about values where we can tell what x and y are at particular points. Those are the points, and I think I know what it is there and there. Otherwise, it gets kind of hard to estimate. And same over here. Well, actually, this is a line, so I know what g of x is in a lot of places. Let's see which one they ask us about when they do an example. Let's zoom out a little bit. Okay, they choose negative 2. Look at that. They've chosen an x of negative 2, and I know f of x at negative 2 has a pretty well-defined, it crosses there at 1. I can see f of negative 2. When x is negative 2, I get a 1. So, f plus g at negative 2, from the graph, I can see, well, f of negative 2, well, let's put it in a form that maybe is less confusing. Remember, f plus g negative 2 means f of negative 2 plus g of negative 2. Just to show that step, even though once I've done it 10 times, I can automatically think that. Let's just make it very clear. F of negative 2, well, here's f. When x is negative 2, I get a 1. So this is f of negative 2 is equal to 1. G of negative 2, can you see what g of negative 2 is? G of negative 2, I find where x is negative 2, and there's where it hits at negative 3. So I know that g of negative 2 is that value, negative 3. So g of negative 2 is negative 3. So equal f is it. So f of negative 2 is 1, plus g of negative 2 is a negative 3. Put parentheses around it if it helps. 1 minus 3 gives you a minus 2. Now make sure, and I'm happy to help you explain this. If there's any confusion in your mind, how I got f of negative 2 is a 1. F of negative 2 means find, and remember, this is our x and this is our y. Find, when x is negative 2, that's right here, where does my graph hit when I have a negative 2 for x? It hits right there. There's my value for y. So f of negative 2 gives me 1. F of 2 also gives me 1. F of 1 gives me negative 2. F of 0 is negative 3. F of negative 1 is negative 2. The others I can sort of estimate, but from this graph, they're going to be nice to me and usually only ask me about f of negative 2, negative 1, 0, 1, or 2. Otherwise, it's hard to figure out what it is. So when you see graphs, if they do ask you for like f of 3, you could say, well, let's see, it looks like it's probably up around 7, but I'm not sure exactly. And let's see how they did that in the book. And we get negative 2. Now, when I have f and g, f times g of 0, from this graph, let's look at f of 0, g of 0. Oops. Slide over. F of 0, what is f of 0? X is 0, I get a negative 3. And g of 0, I get a negative 1. So when they're asking me about f times g of 0, I get negative 3 times a negative 1, and negative 3 times negative 1 gives me 3. So when I have a graph, I can't combine them. I have to figure out f of 0 times g of 0. You could, perhaps in a fancy way, calculate the combination graph, but that's a way more work than you need to do. Just use the two graphs separately. Find out one graph's f of 0, the other graph's g of 0, then combine them. So when you have the graphs, don't try to combine them. You'll just be very frustrated. Adding that graph to that, it is possible, but that's a lot more work than you need to do. When they don't, all they care about is what's f times g at 0. Now, a little practice. See if you can do this. And you can decide which method to use. How would you solve this one? Find the values. Knowing this, these are given. Someone has given me this formula. I have f of x and g of x. And I want to calculate f plus g at negative 2. See if you can figure out what that would be. Try to do it on your own, and then I'll walk you through it. And while you're thinking through it, I'll do the combo just for fun. F plus g is equal to x squared minus 25 plus x minus 5. Is for factoring in case it's interesting. I can see that factors into x plus 6 times x minus 5. Sometimes factoring, when I'm doing the divide, usually the factoring doesn't do much for me. But I just did that for fun, as I recognize, oh yeah, two numbers multiplied give me 30, difference of 1. Well, what do you get? x squared minus 5, let's just plug it in. Negative 2 squared minus 25, that's f of x, plus negative 2 minus 5, because we're looking for when x is negative 2. Well, what do I get? I get 4 minus 25 plus, well, let's just add these together, and then we'll add it, plus a negative 7, or a minus 7. So 4 minus 25 gives me negative 21, and subtract another 7 gives me a negative 28. Well, let's just test it a different way. I combine them. I also see that I get 4 minus 2. That gives me 2 minus 30 gives me negative 28. So negative 28, either plugging in x, plugging negative 2 into here, or plug in negative 2 into the 2 separately. Usually, when they only want a particular value, unless you like going through the work of doing all the combinations, f of x minus g of x, just plug the value of x in separately. So let's just do f of 3 minus g of 3. Well, f of 3 is x, or 3 squared minus 25 minus parenthesis 3 minus 5. 3 squared minus 25 is 9 minus 25. And 3 minus 5 is a negative 2. But I'm subtracting a negative 2, so that becomes a plus 2. And that becomes 11 minus 25, or minus 14. F of 3 minus g of 3. If I want to plug it in, plug a 3 in over here, well, it becomes a 9 times, oh, sorry, that was the f plus g. I'd have to find the combination f plus g and then plug it in, and I'm too lazy to find the combination since this is easy enough to do. But if you wanted to, you could go through the work, find f minus g of x, and then put a 3 in for that. How about f times g of 4? Well, f of 4 times g of 4 equals 4 squared minus 25 times 4 minus 5. Well, this simplifies to negative 1. And 16 minus 25 times a negative 1. Well, 16 minus 25 is a negative 9. So negative 9 times negative 1 equals 9. Now, I'm realizing that factoring, if they give me an x of f over g of, or sorry, that's f plus g, never mind. F over g of 0. Oh, they gave me an easy value. That's f of 0 divided by g of 0. Well, f of 0 is negative 25, 0 minus 25. And g of 0 is 0 minus 5, or negative 5, equals 5. They gave me an easy x to calculate. But what if we did something perhaps a little more interesting? What if we did f over g of 5? What do I get? I get 5 squared minus 25 over 5 minus 5. Well, that gives me 0 over 0. You'd think I should be able to get 1, but nope. It gets close to 1, but then blows up. I cannot divide by 0. That was just a little extra. They gave us an easy one. When x is 0, I get a minus 25 divided by negative 5. Just a little practice given any functions. Any questions about that? I'm hoping by going through it little by little, little harder each time. You know, I didn't realize, on my screen this is red. Why did the colors go away?
It looks red.
Looks really like a dark red to me.
Looks like
It's a, man, I didn't realize it's so different. It's a really bright red over here. Look how red it is there. Must be the projector. Or it could be my old eyes. Some new thing we've discovered. Okay. What's this one? Let's simplify. What is f plus g of x if I have these two f of x's and g of x? This one, they're just wanting us to simplify this. They want us to add them together. What can we simplify? Well, let's see here. I've got 3x squared. No other x squareds around, so there's still a 3x squared around. I've got a 3x there. Adding another 3x with there, because I'm looking at f of x plus g of x. Well, 3x squared plus a 6x. And there's a 5 there. No other constants, so it's a plus 5. Nothing to factor out. If that were divisible by 3, I might pop the 3 out in front of it. But otherwise, there's my answer, just adding them together. Multiplying them together, that's where it gets a little more complex, but let's not panic. Let's just multiply f g of x equals f of x times g of x. Well, that f of x is 2x plus 4. And g of x is 5x squared plus 2x. And remember, when I'm multiplying, you can do the FOIL method, 2x, or you can do the 2x times 5x squared plus 2x times 2x plus 4 times 5x squared plus 4 times 2x. What do I call that? First last plus last first plus last last. Well, let's just do it that way. 2x times all of that. So I get 2x times 5x squared plus 2x plus 4 times 5x squared plus 2x. And now let's multiply that out and put them back together. That becomes 10x cubed plus 4x squared plus 20x squared plus 8x. Combining like exponents, those are the only two I can combine. That becomes 10x cubed plus 24x squared plus 8x. Now, if you wanted to just look at things, maybe make it look a little easier, I see there is a factor of 2 everywhere, and there's an x in everything. So I could say, let's factor. They just said, give me the whole thing. This could be an answer. Or if they do say, now factor that, well, I could make that a 5x. That becomes times 2x squared plus 12x plus 4. Wait a minute. Messed up. 2x times 5x squared plus 12x plus 4. Had the 5 in the wrong place. And maybe that's factorable, but they didn't say to factor. I just noticed that this is where you can stop. Sometimes factoring makes future problems a little easier, especially when you're doing the divides.
If you put your answer as the second one, would it be counted wrong? Would you count it wrong?
This one here?
Yeah.
No. I'd say, good job factoring, as long as it does the correct factor. And I'm not even going to do the slide and divide. I don't see it jumping out at me if that's solvable to factor that out. I could do the quadratic, but I'm not going to. Now, this should be easier, but sometimes this is confusing because you're in a different world. You're not thinking math, you're thinking graphs. Well, what are they looking for? F plus g of 0. Think to yourself, that's f of 0 plus g of 0. All right, f of 0 is where is x equal to 0? What do I get? I get a 5 for f. For g at 0, when x is 0, I get an y of 0. See how that is? F of 0 is a 5. G of 0 is a 0. Remember, horizontal axis is always my x. And they often forget to label that for you. So even though they say g of x, what that says is, oh, what's horizontal is the x values. Unless they label them different, which sometimes they do when they talk about other crazy functions, the horizontal line is my x. All right, let's do a couple more then. F minus g at 1. F of 1 minus g of 1. Automatically put that in your work. And f of 1, when I have a 1 here, f of 1, this gives me a 4. This is my f of 1. F of 1 is 4. G of 1, here's I have my 1. There's my g of 1, is 2. F of 1 minus g of 1 equals 2. F times g of 2, automatically think to yourself, f of 2 times g of 2. F of 2 is, here's my x of 2, my f of 2 is 3. F of 2 is a 3. So f of 2 is a 3. G of 2, here's where x is 2. I get an output of 4. That's my g of 2. 3 times 4. 4 equals 12. And then finally here for the last little practice with graphs, f of 4 divided by g of 4. And g of 4 better not be 0 or I'm going to blow up. F of 4, x is 4, I get out a 2. So f of 4 is 2. Put a 2 there before I forget. 2. G of 4, come up here. X of 4, output is another 4. That's my g of 4. Now notice this is a crazy mathematical function. Normal quadratics don't have corners on them. They're curvy. Well, this is measured numbers in a graph that we've been given. All I know is g of 4 is 4. So g of 4 is a 4. And that simplifies out to 1/2. So I'm hoping by going through this, now algebra of functions shouldn't be so scary. Now let's go back to that very top thing. And I'm thinking this probably looked pretty scary at the first, all these f's and g's around. But take them piece by piece, and it's really not that complicated. Yes?
I think you're going a little too fast for everyone. I've seen like everybody stop trying to take notes after like 20 minutes.
What do you think? It is recorded, so you can go back and watch the recording if some got stuck on anything. And in the middle, tell me right away in the middle, hey, can you slow down a bit? I'm happy to slow down. I wasn't noticing how many notes, because I know sometimes with a class this long, it's sometimes hard to take notes the whole time. You are okay to stop taking notes, relax a little bit, especially when we got to the graphing parts. Sometimes you do have to sit back and say, well, let me think about this, and I'll go back and watch the video. But be sure, if in class, if I'm going a little fast, say, hey, Mr. Mann, could you go back and go back over that? And because you're paying for this, so let me know if that ever happens. So yeah, thanks for the comment. And I'm happy. If there's anything in particular that it became really fuzzy and I need to go back to, I'm happy to do that because we got just a little time to kind of relax and review. Or we could start taking a little look at the next section. What do you think? Are you ready to go look at the next thing for a little peek? And we'll be spending more time on Tuesday. Ready to go ahead? Take a little break. Now, hopefully that's it. No, let's just go back to what I was mentioning. When we first looked at this, and this happens to me too when I'm looking at something new, you see a lot of F and G's and X's. It's like, oh man, this is really scary. I'm never going to understand this. Just focus on that part. And even cover that up. Just say, no, I'm not going to even think about these others. Let me understand just that one thing. Then, the next thing. It's so easy when you see all of that, like, oh man, I'm never going to understand that. And your mind automatically, done, I can't do this. Just say, okay, I'm going to work on just that first part. Adding F and G's. Subtracting F of X and G of X. Then, multiplying, dividing. After working through, I'm hoping this doesn't look so scary. But a little more practice, maybe reviewing the video, you'll say, wait, maybe it's not as scary. It's still a little challenging. But as you practice, or even work through the video practicing, and remember with the video, jump ahead to little parts, replay little pieces, and then you can come. And I'm hoping then you'll think, wait a minute, I'm getting this little by little. Okay, let's just take a little start at this one. You don't have to take notes on this one. We'll review this on Tuesday because it's been a while. We got about 5 minutes just to start thinking about the next thing coming. So far, we've added functions together. We've done f of x, g of x. But what in the world are they doing here? F of x plus 1? What? Well, don't panic. I know what f of x is here, right? I have a quadratic function. F of x is this. F of x plus 1, all that means is wherever you see an x, put x plus 1 where you see the x. So f of x plus 1 becomes 3 times x plus 1 squared minus 2 times the x plus 1 goes where the x was, plus 11. Now we can multiply that out and figure out what the function is. But the key thing here is f of x plus 1 is like saying, another way to say that is I have a g of x is defined as x plus 1. And f of x is 3x squared minus 2x plus 11. I can say f dot, or circle, or composite f of g of x. We're not doing f times g, we're doing f composite g. That, think to your mind, f of g of x. Kind of crazy looking. I put g of x where the x was. That's the same as saying wherever I see an x, put a g of x where you see x and do the same thing to g as you were doing to x. It's one more level of, call it abstraction, complexity in the algebra. So don't worry about knowing any calculations. Just recognize if I have some function defined as this, and I have some function g defined as this, I actually don't like this format. I prefer to, when I see this, I automatically think in my mind, I take f and I put g of x wherever I see x. I think this is easier to understand. I always write it this way immediately. That f composite g, you're going to have to remember that it's called the composition of functions. But all that means is wherever you see an x, when I had f defined, put g of x where you see that. Like we did here. We had g of x, x plus 1. Wherever we see an x, put the x plus 1 there and square it. This is what we call a combination, or composition, f of g of x. And that's where we'll start next time on Tuesday. Anything with the video, I'll immediately upload that in the playlist. You can go back and review anything. Have a great day. Oh, and I have, if you didn't get your, what's that?
I think you messed up one of mine. I only got 3 back and I
Yeah, what's the last name again?
Waggle.
Might have accidentally. No, I might have fallen in like cushion or something. I'll take a look. Remember which one it was? Anyone not get their
I don't know which
papers
one
back?
it was. I just know that like I took 4 tests because I did the retakes
Yeah.
twice, So I should have 4. But I only
Okay,
got 3.
I'll check to see if I have some sitting around. I might have accidentally dropped it.